So, in the last classes, we discussed about the different CNN architectures. We talked about AlexNet, then we talked about VGG. Next, we talked about InceptionNet, and finally, we talked about ResNet or residual networks. So, let us just take a quick back to all of what we have studied. Then we will go and understand about the later versions of InceptionNet. So, let's come with the starting AlexNet. So, it starts with an image 227 cross 227, obviously cross 3 because it is an RGB image, and then what it will have is it will have convolution layers and they will be followed by max pooling, and this goes on until finally you have 3 convolutions one after the other. It has 5 convolution layers plus 3 fully connected layers. The final fully connected layer has 1000 neurons, softmax with softmax activation, and the other thing about AlexNet is it uses big filters like 11 cross 11, 5 cross 5. Then we come across VGG. So this is short for Visual Geometry Group, and this was actually released by researchers of Oxford University, and VGG has different depending upon the layers. So VGG is different depending upon the layers. You have 11 layer VGG, 13 layers, 16 layers and 19 layers, right? The interesting thing about VGG is it showed how one 5 cross 5 filter can be replaced with 2 3 cross 3 filters. So what this helped us in doing is it helped us in reducing the parameters for training. That was one optimization. And the other thing about VGG was it had 2 convolutions one after the other, then it was followed by a max pooling, then 3 convolutions maybe, and then max pooling, and so on. So this helped increase the number of layers obviously, but at the same time it helped in reducing the number of trainable parameters. Now we will talk about InceptionNet. So InceptionNet is basically when they decide that we should even go wider as well as deeper. Now you might be thinking why I am revising the whole thing over and again. So the reason why is, see, it is easy to teach once and it gets over, but if you listen to this over and over again, it just gets ingrained in your brain, and then it is very difficult to actually forget. So the whole point of InceptionNet was to go wider as well as deeper. So here they use convolution of different sizes to achieve that. So you have 1 cross 1, a 3 cross 3, you have a 5 cross 5, and then you have one max pooling, and then all these are connected to previous layer and then concatenated to form the next layer. So this was the whole thing about InceptionNet module. This was the basic structure, naive module, and if you add the dimensionality reduction, it has a 1 cross 1 in front of all of these. So this was the whole thing about inception module. So it has, I suppose, 9 such inception modules, and 27 layers including max pooling, and other than that it also has 2 auxiliary classifiers. So the final loss was basically the summation of the final loss from the final softmax layer as well as 2 auxiliary classifying layers. So this was auxiliary layers were only used at the time of training. It was not used for inference or testing. So this was everything about InceptionNet, and the final we had was ResNet. So ResNet, which is short for residual networks, this helped us in going deeper. What they did was they added here in this format X, and then this is a weight layer, this goes through ReLU, then you have here, which is a summation, you get f of x here. This here goes as a skip connection. You add both of the things, and then this again goes to ReLU. This is again a weight layer. So this was the whole thing about a residual model. So now that we have understood all of this, we will now go and understand about different later versions of inception modules. Okay, so once again you have the whole thing, and it is very very important, I am saying again and again, to actually know and understand this, because this is actually going to be asked in interviews. You need to understand the whole thing. So what was anyway, what was with the ResNet, what happened is it helped to solve the problem of network degradation. Okay, now let us start with Inception V2. By the way, quick fact, Inception V2 and V3, that means Inception version 2 and version 3, actually were released by the same paper, in the same paper. So there is not a very big difference between version 2 and version 3. So let us understand this first. So what happened was, the very first thing that you will see is, when using inception layers, they used 5x5 modules, right? So what they have done is, if you remember in VGG also, they found out that one 5x5 can be substituted with two 3x3. This helped in reducing the number of trainable parameters. So this is what they have done. Everything remains the same except for this part. This 5x5 is now two 3x3 layers. Let us call this figure 1. Okay, and this is basically the substitution here, or let us call this module 1. Whatever you can call this, because they have not given any specific names for this, not in this module at least, in this paper at least. The next thing what they have done is, what they saw is, you can actually break down symmetrical kernels into two asymmetrical kernels. So what that means is, suppose I have a 5x5 module, okay, so this can actually be broken down into 1x5 and 5x1. so this helps in reducing the trainable parameters by a lot. So if I have, let's say, 3x3, and if I substitute this one kernel with two convolutions of 1x3 and 3x1, this helps reduce the computation by 33%. So here what they have done is, this n being the actual value that you can use, whatever be it, so they have used 7 actually, but yeah, here they have written n. So this now n cross n that we were using here will now be replaced by 1 cross n followed by an n cross 1. In the same way here again, 1 cross n followed by an n cross 1, and the same way here. So let us call this module 2, inception module 2. So these are the there are 3 changes actually, and we will actually understand this. Now let us come to the third part. Here what they have done is, when we are going wider, let us go even more wider. That is the whole concept of this, okay. So here 3x3 we were doing, followed by another 3x3. Instead of doing one other 3x3, it goes for two other different convolutions, 1x3 and 3x1. So in the same way here, instead of doing 3x3 directly, 1x3 and 3x1. Okay, so let us call this module 3. So now we have 3 different modules. If you remember, what they have done is, even Inception version 2 follows everything that was there in Inception version 1. That means it makes sure that the whole model is, or the whole architecture is very well engineered. That means it is very well defined. It is very well optimized as well. So you have 3 different modules in Inception V2. So what are the 3 modules if we go back? So what they have done is, they have removed the 5x5 with 2 3x3s, right? That was the first one. The second one, what they have done is, they have factorized the 3x3 into 1x3 followed by a 3x1. And the final thing that they have done is, they have gone even wider, and instead of using one 3x3, they have done is, it divided into 2 as 1x3 and 3x1. So these are the 3 modules. Now this is the actual structure of a Inception V2. So look here, you have convolution 3 cross 3 followed by this. So this whole part, this is known as the stem part. The stem part is the part where everything goes straight. There is no difference here, okay? And then it is followed by the inception modules or the inception parts. So the stem part is basic convolutions. So you have convolution of 3 cross 3 with a stride of 2. Then you have again a convolution. Then you have padded convolution and then pooling. Then again 3 more convolutions. So this is the stem part. The next part what they have done is they have used 3 inception. But the inception is as in figure 5. This figure 5 is basically module 1. That is, instead of 5 cross 5 they are using 2 3 cross 3s. So it has 3 inception modules of this kind, module 1. The next thing is they are using 5 inception modules as in figure 6. Figure 6 is basically module 2. So here what they have done is they have symmetrically broken down the kernels. So instead of 3 cross 3 they are using 1 cross 3 followed by a 3 cross 1. So they have 5 such inceptions, and the final they have done is 2 inception modules as in figure 7. This is basically module 3. In module 3 what is happening is they have gone even wider. So 3 cross 3 is no longer 3 cross 3 but it is basically 1 cross 3, 2 convolutions, one is 1 cross 3, the other is 3 cross 1. So this is basically what has happened here. So figure 5, 6, 7 are basically module 1, module 2 and module 3. You need to remember these modules very well, like really well what is happening, because this is a very optimized architecture. Like I am saying again and again, it is very optimized. So they have made sure that the kernels are very optimized, so you get the least number of trainable parameters possible. Okay, so this is everything you had to know about Inception v2. But there are also other things that they have improved, not just this thing. Okay, these 3 modules they have added, nice. So now what they have done is, other than that, they have improved the learning rate. So they have improvised on the learning rate. They changed the learning rate. Secondly, what they have done is they have removed dropout. So there is no more dropout anymore, because it is already a very sparse network. If you see, it is very wide. So they have removed the dropout concept. Next, what they have done is they have decreased the weight of L2. So that means earlier in Inception v1, the weightage that was given on L2 regularizer is now decreased. So it is given less weightage. Then what happened is it accelerated the decay of learning rate. So when we talked about the decay, what decay basically means is, after, if you remember in the last one when we talked about, it was 4% of decay rate for every 8 epochs. So what that means is every 8 epochs the actual learning rate will decrease by 4%. So what they have done is now they have even accelerated that part, so it will decay even more faster. They have removed local response normalization. Like I said, if you remember, that local response normalization was earlier used but it is not used anymore. So they have finally realized that and removed local normalization. And final thing is they have reduced image distortion. So any image that could cause the distortion has been removed. So these are the changes that were done from version 2 along with adding these 3 modules, right? But remember, right now these modules have not been named. I have just named it for the sake of understanding, but right now they have not been named. Later on they will be named. Now let us talk about version 3. Like I said, version 2 and version 3 were released in the same paper. So there is not a very big difference between version 2 and version 3. The changes that have happened in version 3 is basically they have added batch normalization in auxiliary branches. You remember the auxiliary branches? They were the extra branches that came out after a few inceptions, and there were 2 such auxiliary branches. So these were basically used while calculating the loss. So the actual loss was basically the loss from softmax plus 0.3 into loss from auxiliary 1 plus 0.3 into loss of auxiliary branch 2. Yeah, so that is how it was calculated. Auxiliary 1 and auxiliary 2 were given a weightage of 0.3, and the rest of the weightage was from the actual loss from the softmax layer. So firstly, it added batch normalization to auxiliary layers, giving it a bit of regularization. Next, they added RMS prop as optimizer. The next thing, they factorized 7x7 factorization. So what that means is, if you remember, we were doing, if you had 3x3, it was broken down into 1x3, and this 1x3 was followed by a 3x1. This was module 2, if you remember. So here what they have done is, they have used inception, but they have factorized 7x7. So it will be 7x7 will be factorized as 1x7, and this 1x7 will again be factorized or convoluted with the 7x1 kernel. So this is basically 7x7 factorization. And finally what they have done is, they have added label smoothing. So label smoothing is basically a regularizer again. What this does is, basically it gives you the power so that the model cannot very confidently give you the outputs. So the model will not be able to give very high confidence to the value. So if suppose the model knows that this is a dog, the image is of a dog, and it is a correct one, and it cannot give very high answers like 0.99. It has to reduce the confidence. That is where label smoothing comes in. Now let us talk about Inception v4 and Inception ResNets. So these again, like V2 and V3 that came out from the same paper, Inception v4 and Inception ResNets have also come out from the same paper. So the structures are going to be very similar. I mean, not a lot similar, but yeah, there are a few similarities that you will find out and understand. So what is this? So this is the structure of Inception ResNet v1, and this is the structure, the stem structure basically, of Inception v4 and Inception ResNet v2. So one thing that you need to know is, Inception ResNet v1 was basically a combination of, so when we talk about Inception ResNet v1, this was basically, or Inception ResNet as general, what this means is, basically it has combined ResNet and Inception blocks. So these two modules have been combined. We will see how this has been combined, but yeah, the whole idea about Inception ResNet is basically a combination of ResNet and Inception module together. Okay, so what I was saying is, Inception v3 is very similar, the stem things are very similar to Inception ResNet v1, and Inception v4 is very similar to Inception ResNet v2. So this was v1. So Inception v3 is very similar to Inception ResNet v1, and Inception v4 is very similar to Inception ResNet v2. So like I said, this is the Okay, so this is basically the stem structure of Inception ResNet v1, and this is the stem structure of Inception v4 and Inception ResNet v2. The stem structure, if you remember, is those structure that was there before the Inception modules. This was the stem structure. So the changes that they have done is they have made some changes in the stem structure. So this is the basically stem structure. These are now the modules. Now this time the modules have been named. So we have module A, Inception module A, module B and module C. Okay, so this is basically module A, then you have module B, and finally you have module C. If you look into this properly, what is happening is, first of all, they have, instead of max pooling and average pooling, right, they have used, instead of 1 5x5, 2 3x3. Right, this was there in Inception v2 also, but in that time it was written as figure 5, figure 6 and stuff like that, but now they have actually named these modules. Okay, then here the next part that we talked about, you remember in Inception v3 what I said, they have factorized 7x7 kernel. So if you look here, you have a pooling which is followed by a 1x1 convolution, like here the same thing. Then you have a 1x1 convolution. Here 1x1 convolution is there to reduce the dimensions, and here instead of using a 7x7 convolution, they have factorized it to 1x7 and 1x7. Then again you have here, this is again a factorization of the whole thing. So this is basically the whole thing about module B. And finally you have module C. In module C, like I said, what they have done is they have gone even wider this time. So you can see here you have a 1x3 and 3x1 instead of one after the other, like it was there in here 1x3 and this was followed by a 3x1. But no, this time it is different. Here you have in a wider space 1x3 and 3x1 in the same layer. Same thing here that they have done is, and here you have a factorized module. So this is module C. So this is Inception module A, module B and module C. This is basically used in both v4 and ResNets, Inception ResNet, sorry. Now here we have is reduction blocks. So reduction blocks are basically used to reduce the size. So instead of going for pooling directly, what they have done is they have used reduction blocks, and what that means is now you can reduce the sizes. So here this reduction block is reduction block A. This is reduction block B. In reduction block A, this is used to change the dimension from 35x35 to 17x17, and this reduction block is used to change the dimension from 17x17 to 8x8. Okay, now here you have one max pooling layer, one convolution, and then again two convolutions one after the other. So this is basically what they have done is, this is to reduce the dimension without actually going through just pooling. They also have convolutions here. In the same way, here also you have convolutions and max pooling, and you have factorization here, and here also you have 1x1 to reduce the dimensions. So this is basically the whole thing to reduce the blocks. There has not been written a lot about this in the paper, but they are used to reduce dimensions is all. And then now we come across Inception ResNet. So these are the modules for Inception ResNet. Okay, so now first, before we go into Inception ResNet, let us just revise very fast what we have learnt about Inception v4 as now. So the first thing is the stem is changed. So the stem is no longer how it was there in v2 and v3, it has changed. The next thing is they have finally named modules like A, B and C. So inception module A, inception module B and inception module C. Then the third thing is they have added reduction blocks, block A and block B. Okay, so this is the whole thing about inception V4. Now let us go and understand about inception ResNet. So these are the modules for inception ResNet. Like you can see here, this part is the inception module part, and this here that you have, this connection, this is a skip connection, and this skip connection is from basically the ResNet part. If you remember, what happens in skip connection is you have the weights and layers and convolution and everything, but you skip all of that and add it to the final output. So this is what the addition is happening. So this is f of x and this is x, and these two get added here and then they are passed to a ReLU activation. So this is the residual block net, and this part is the inception part. So now you can understand what is happening. Okay, so here what they have done is, again, one thing that you need to be very clear about this is, in inception ResNet modules, to actually add the values, your f of x and x should be of the same dimensions. So that means your input dimension should be equal to output dimension. So that means you do not have any max pooling layer, that has been removed, number one, because that will reduce the dimension, because you are adding f of x and x. If they both have different dimensions, you will not be able to add it. So to add this whole residual block to inception blocks, you have to have input dimension equal to output dimension. Hence you do not see any max pooling layer in the inception module anymore. Here again, see, they have added this part now. They have a symmetrical factorization that they have done here. And finally, here also you have asymmetrical factorization. So now these are the basic inception ResNet blocks. So this is block A, this is block B, and this is block C. Here are the reduction blocks again. So this is reduction block A and this is reduction block B. They are similar to inception V4 reduction blocks. So the blocks are not changed. Again, this is used for 35 cross 35 to 14 cross 14, and this one is used to reduce from 14 cross 14 to 8 cross 8. So here also you have the same thing, max pooling, 1 convolution and 2 3 cross 3 convolutions. After 1 cross 1 convolution, this 1 cross 1 is basically to reduce the number of parameters, to reduce dimensionality. Then you have here max pooling. Again here you have 3 cross 3, 3 cross 3, and then 2 3 cross 3 instead of 1 5 cross 5. So this is the whole beauty about InceptionNet. The whole thing has been so very well structured, so very well designed, that it uses the least amount of possible weight. It has been optimized in the best way possible, but it also gives us the best results. So this is the whole thing basically about reduction blocks A and B. And then finally here you have, this is inception V4 structure, the whole structure of V4. If you remember, I showed the structure about inception V3. It was there in a table. So this was the structure of inception V2 and V3. They were both released in the same paper. This is the structure of inception V4, and this is inception ResNet. So like you can see here, you have input, the stem. I showed you how the stem looks like for inception V4. Yeah, here this was the stem for inception V4, and this was the stem for inception this was the stem for inception ResNet. So this is the stem for inception V4 and inception ResNet 2, by the way, and this is the stem for ResNet inception ResNet 1. Do not get confused. I get confused here a lot. So you have the input, this is followed by the stem part that was there, then you have inception module A, reduction A, inception module B, reduction B, inception module C. This is followed by an average pooling. Average pooling is basically used to reduce the number of dimensions like pooling, but it also helps in reducing the number of parameters required for training. This is followed by a dropout and final softmax layer. Dropout is kept at 0.8. This is for Inception ResNet. Here you have input. The stem is different for Inception ResNet V1 and V2. So the whole thing about this thing is the stem is different. The stem of Inception ResNet, okay, let me just write this and make this clearer. So the stem of Inception V4 and Inception ResNet V2 are similar, and the stem of Inception ResNet V1 is different from this. Okay, so the whole difference is in the stem and also some hyperparameter tuning. We will come to that. So you have a 5 Inception ResNet module A followed by reduction A, and then Inception module B, reduction B, C, average pooling, dropout and softmax. Okay, so this is basically the whole structure of Inception V4 and Inception ResNet. Now let us come to something else. So the computational cost of V1 is very similar to that of, by the way, okay, when here I will be mentioning, let me just not do it that way, it will be easier if I just do it. So computational cost of Inception ResNet V1 is very similar to that of Inception V3, and in the same way computational cost of Inception ResNet V2 is very similar to that of Inception V4. Okay, so this is one thing. Stem of V4 and Inception ResNet V2 is similar. So Inception ResNet V1 and Inception ResNet V2 have different stems. So you need to understand one by one. This is the first point, this is my second, this is the third point, this is the fourth. In Inception ResNet V1 and Inception ResNet V2, the stem is different. Other than that, the modules are same. So reduction A, B same with reduction A and B. Inception ResNet module ABC is same, and difference is in hyperparameter tuning. So this is the whole thing, and this can be also known as the differences between Inception ResNet V1 and V2. And like I said, the important thing in Inception ResNet, that one thing we need to be make sure is that in the modules the input and output dimensions are similar. The original paper did not use batch normalization, and one thing that was found out in Inception ResNet was with very less epochs, it was able to achieve very high accuracy. So this is everything that we need to know about the different later versions of Inception ResNet v1. Before that, let us just quickly revise what all we have gone through, because I know this is a lot, and even though this is a lot, it is very important and it is used a lot. So we have firstly the different modules, and these modules were not named in Inception v2. This is very important, and please remember it. Inception v2 and v3 were released in the same paper, and they were not used in Inception. The names were not given in Inception v2 and v3. However, they were used. What were the modules? First of all, instead of 1 5x5, they were using 2 3x3. This was the first part. Secondly, they factorized into symmetrical kernels. So instead of using 1 5x5, they were using a 1x5, which was followed by a 5x1. And final one, the third module, was basically, instead of using here in this manner, where this would have been 1x3 and this would have been followed by 3x1, this module here divides this into two parts, and 1x3 and 3x1 are in the same layer, same category, okay, instead of one after the other. So this is the module 3. Then we had the whole structure about Inception v2 and v3. The differences between v2 and v3 was basically they removed learning response normalization in both. In v3, what they did was they were using RMS optimizers. They improved the learning rate and dropout and everything. These are the different points that are used as changes that was there from in v2 when you compare it with v1. And then these are the changes that were there in Inception v3 when you compare it to v2. Okay, and important thing here is they added a label smoothing so that the model is not giving very high confidence to a particular label. Then we have Inception ResNets, and before that we have Inception v4. In Inception v4, what they did was they changed the stem layer, okay, and Inception v4 and Inception ResNets were released in the same paper. Then you had modules. Now this time they have named the modules, and these are the different Inception modules, Inception v4 modules, and they also added this time reduction blocks. So these are the different reduction blocks. One thing that you need to know about this is when you are factorizing this asymmetrical factorization, it cannot be used all the time, okay. Let me talk about this one. So if you have a 5x5 and you are changing it to 1x5 and 5x1, you cannot use this in the stem layer, because during the stem layers they have very high dimensions. So the dimensions are like 224 into 224, and this asymmetrical thing will only work when the values are between 12 to 20. So when the dimensions are between 12 to 20, only then will this asymmetrical thing work. So that is why you will be seeing that even in Inception, when you are building the whole model, when you have this structure here, you have the stem layer, okay, and there is no Inception used here. Then you have Inception A. Even in Inception A, they have not factorized it into asymmetrical kernels. They have reduction A, and then finally they have here Inception B, because we know that this factorization will only work where the dimensions lie between 12 to 20. Hence it is used only in Inception B and Inception C, not in Inception A. Just look at the drawing again, you will realize this. So here you can see there is no factorization, asymmetrical factorization, no such thing is there. Here you have asymmetrical factorization, and finally in here what they have done is they have used even more wider approach to this going deeper instead of this going deeper, and they have reduction blocks. Reduction blocks basically are used so that we do not directly go and reduce the value using max pooling or some other pooling, but we also add some convolutions to it so that it is reduced even more smoothly. So this was the whole thing about Inception v4. Stem is changed, modules were added ABC, and then you had reduction blocks. Now you have Inception ResNet blocks. Important thing to remember about Inception ResNet blocks is when adding the skip layer, since we are adding a skip connections, our input dimension should be equal to the output dimension. Hence there is no dimensionality reduction here. What can be used is to increase the channels or something like that. So you have convolution here which represent the Inception module, and then you have skip connection here. This represents the ResNet part, And in the same way you have Inception ResNet A, then B, and then C. These are reduction modules so that you can reduce smoothly instead of doing a simple max pooling. And then finally you have the whole structure as is. Now we discuss about the differences. So the differences between Inception ResNet V1 and V2 is basically the stem structure and the hyperparameter tuning or hyperparameter setting. And the similarities between Inception V1 and V2 is, well, they both have the same reduction blocks and they both have the same Inception ResNet modules. Okay, so this is the whole thing, the whole point of this thing. And in the next class what we will do is we will talk about ResNet versions. So what were the later versions of ResNet? And even though there are a few, they are not very used a lot. So the whole thing about ResNet, the future versions of ResNet, was this Inception ResNet module. And since we have already discussed that, we do not have a lot to discuss when it comes to ResNet versions. But there are a few and we will discuss that definitely. And finally, what we will do is, now we will, since we have completed everything there is about these models, one thing you need to know is these all models, these all CNN models, they are usually used for classification tasks. So we will be able to say after that, we will do some coding and everything, and then we'll be able to say, okay, so now I have completed the whole classification part. So I'll be able to classify images. Then we'll come to different parts, then you have detection and everything. I mean, the whole thing, there is a lot. But yeah, that's it for today. I hope you enjoyed the class and keep learning.